All right, let's get right into it. Today, we're going to talk about the invisible architecture, the thing that's really going to decide who wins the next massive tech revolution, humanoid robotics. And you'll see, it's not just a fight over who builds the best hardware, it's a battle to create a totally new kind of intelligence.
So let's start with a number that kind of sets the stage for everything else. $50 trillion. That's the mind-blowing size of the market that NVIDIA CEO Jensen Huang sees for humanoid robotics. And what's driving it? Well, it's a huge and growing global worker shortage.
The stakes here are just immense. This isn't about some niche robot for one or two factories. We're talking about a future where robots are as common as cars. Elon Musk even thinks they're going to far exceed the population of humans one day. Okay, but to get from where we are now with these cool prototypes to a future with billions of robots, we have a monster of an engineering problem on our hands. It's what you could call a crisis of scale. And frankly, the way we manage complex systems right now, it just can't solve it. Just take a second and really think about that question. How do you manage 1 billion robots? When you go from managing one robot, or even a few thousand, to a billion, the complexity doesn't just go up, it multiplies like crazy. It's an explosion of complexity. So in computer science, there's this little term that perfectly describes the problem. O of n squared, or big O of n squared. It basically means that as you add more things, in this case that's our robots, the n, the number of possible connections between them just blows up exponentially. It would create this unmanageable data storm for any kind of central system. And look, this isn't just some small technical issue. It's a brick wall. A single central server trying to get data from a billion robots, it would grind to a halt. You'd have insane delays, the cost to build that infrastructure would be astronomical, and you'd have all these single points of failure. At that scale, centralized control is just technically and financially impossible. It doesn't work.
So, if that centralized approach is a total dead end, we obviously need a whole new way of thinking. And the solution is a pretty radical shift in how we build these things. It's called the hive mind paradigm.
The answer is a hive mind. It's a decentralized network where robots can learn from each other almost instantly. So instead of one big central brain trying to control everything, you have billions of smart agents out in the world, and they only share their most important, most critical experiences. This lets the whole fleet get smarter without creating that central bottleneck. And what's really fascinating is where the inspiration for this comes from. It's not from some new algorithm or computer chip. It actually comes from a very unexpected place. It's based on this 19th century Prussian military idea called Auftragstaktik. The concept was simple. Commanders were told the what and the why, the big objective, but the how was totally up to them. If you apply that to robots, it means each one has the local autonomy to figure things out on its own. But it reports back any critical problems or new things it learns. This is how you let billions of robots act on their own, but learn as a single collective. Now, this hive mind idea isn't just some cool theory. It's actively shaping the race for who's going to dominate robotics. And it's created this really interesting split, a kind of philosophical battle between two very different ways of building the future. And this table really lays out those two competing ideas. On one side, you've got Shenzhen's hardware-first strategy. They are masters of the supply chain, and they're pumping out these incredibly capable low-cost robots. Then, on the other side, you have Silicon Valley's systems-first approach. Their focus isn't just the robot itself, but building the whole integrated network, the nervous system, where every single robot makes the entire fleet smarter. And if you need proof that this is real and happening right now, look no further. A recent Tesla patent for their data pipeline is basically a perfect blueprint for this hive mind approach, and it's an architecture they've already proven works across millions of cars out on the road. So, how does it actually work? Well, instead of just streaming endless, useless video data all day, the system in each car is smart. It watches for weird stuff, anomalies, unexpected events, what we call edge cases, and then it only uploads those really important information-packed moments. This is how the entire fleet can learn from one car's unique experience, and it does it super efficiently at a massive scale. So, what does this all mean for the competition? If this systems first, hive mind approach is the key, well, it means the whole definition of what gives a company a lasting advantage, what we call a competitive moat, is changing in a big way. For years and years, the goal was simple, right? Build a better robot. get better hardware, better motors, better sensors. That was the old mode, but that's not the game anymore. The new mode, the one that's going to be way harder to cross, is all about orchestrating that collective intelligence through a completely integrated system. The new moat isn't just about having good software. It's the extremely rare ability to stitch together the hardware, the software, and the processing of just unimaginable amounts of data into one single learning machine. That's the real barrier to entry, mastering complexity on a planetary scale.
So if you're just focusing on building a better piece of hardware, no matter how amazing it is, you're basically perfecting the horse and carriage right when the railway is about to be invented. You're optimizing for a world that's about to disappear. So here's the bottom line. The company that wins this $50 trillion prize won't be the one that just builds the best individual robots. It's going to be the company that can orchestrate a symphony of learning across billions of them, creating an intelligence that's way, way bigger than the sum of its parts. And that leaves us with the ultimate question, doesn't it? Who is going to win this race? Because the answer won't just define the next 100 years of technology. It's going to redefine the very nature of work and society itself. The race is definitely on.